Okay, guys, so we're going to move on to chapter 18, which is a continuation of differentiation. So today we want to talk about something called the chain rule, and that deals with like composite functions. So, for example, we might have y equals 2x plus 3 to the seventh power. We may have y equals sine of 3x, and we might have y equals e to the x squared plus 9. Now, we're looking at these functions, and immediately we recognize them from chapter 16. We recognize this as x to the seventh, but there's that other function inside. We recognize them as sine of x, but there's that 3x inside, or another function. We also recognize this as e to the x, but there's that function up there. What we're going to do, I'm not going to talk about, I'm just going to show you the mechanics of it. You can read it in the book, and you can read the notation, the s, the g's, the u's, the y's. Simply put, sorry, I'm going to make magnetic rectangles here. We're just going to simply, for a second, we're going to ignore what's in there and say, fine, y prime is 7 times whatever's in there to the 6. But then we're going to multiply it, or let's see, there's a g of x in there. We're going to multiply it by the derivative. Same idea with sine of 3x. Let's put g of x over. Let's call that g of x. Once again, we're going to take the derivative of whatever that thing is, but then multiply it by the derivative. So once again, thing to the 7th power becomes 7 thing to the 6th times the derivative. Sine of thing becomes cosine of thing times the derivative of that thing. Same idea here. What do you think it is? Same idea. The derivative is also e to this function times its derivative. Well, let's finish this up. So we have final answer. Y prime is 7 times, what was the original function? Oh, 2x plus 3 to the 6th times 2. Final answer, 14, open parentheses, 2x plus 3 to the 6th. What's going on with the second problem? Okay, well, the function was 3x. So y prime is cosine of 3x times the derivative, which is 3. Final answer, 3 cosine 3x. What do you think is going on with the last one? Try it on your own. Okay, well, we know it's y prime. We know it's e to the x squared plus 9. The derivative is 2x. Let's put that in front. So the final answer is 2x e to the x squared plus 9. What are some other problems we can look at? Well, how about I give you 1, if y equals 1 over 7x plus 2. So you say, you know what? I recognize this. An easier way, get things out of the denominator. So rewrite this as y equals 7x plus 2 to the negative 1. And then once again, this is just another polynomial, like example number 1. So what do you think? Okay, so we have y prime is negative 1, 7x plus 2 to the negative 2 times 7. Let's clean this up. How do you think we're going to clean this up? Well, negative 7 over 7x plus 2 squared. We leave it like that. How about you try this one? Y equals, how about a radical 6x plus, well, how about something interesting? How about we make it x squared plus 2x minus 5. So we have a function here How are we going to take the derivative? Well, once again, it's just an exponent. Rewrite as y equals x squared plus 2x minus 5 to the 1/2. You follow it through. We have y prime is equal to 1/2, open parentheses, 2x plus 2, I apologize, x squared plus 2x plus 5 to the negative 1/2 times 2x plus 2. Let's clean it up. What do we have here? We actually have, are you ready? Are you ready for the magic? X plus 1 over the square root of x squared plus 2x plus 5. I want you to think about that. How are we doing for space? Excellent. Shall we move on? Y equals sine to the 4th power of 3x. Sometimes you might have to do the derivative twice. Sometimes you might have to do the derivative twice or 2 or 3 times. Take it slowly. Follow the rules. Step 1. So what do we know here? It's y prime. So I'm going to rewrite. I'm going to rewrite this as the sine of 3x quantity to the 4th power. Take it slowly. What's the next step? Good. You know, y prime is 4 times the thing to the 3rd power times the derivative of this whole thing. I'm introducing this notation now. This is an operator, and it's going to be the derivative of whatever's inside of there. So this part is taken care of. Now I have to take part of this. Well, we just did that over here. So we know it's y prime is equal to 4 times sine of 3x cubed times cosine of 3x times 3. Cleaning it up totally, we have, ready? 12 sine cubed of 3x times cosine of 3x. 2 things here. I wasn't here for trigonometry with you guys. But remember, this is the way we put the 3 in here, but it means when you see a trig function squared or cubed, it means the whole thing is squared or cubed. And once again, this is an operator. I'm going to reintroduce it. This d dx. Do you see me? This d dx, that means the derivative. It looks long, but you just take it slowly. Let's try another one. No. Oh, and then the book introduces these. This is kind of interesting. They ask you now to find if y equals secant x, find dy dx. This is just a notation for the derivative. How are we going to find the derivative? Well, I'm going to write this as cosine x to the negative 1. And then you just use the chain rule. This is wrong. This is y. This is a rewrite. And then the derivative is negative 1 cosine of x to the negative 2 times negative sine of x. Let's clean this up a little bit. We have sine of x over cosine of x, cosine of x. Final answer, what's sine over cosine? That's tangent of x times secant of x. It's kind of interesting. Try the other 2 on your own. Try y cosecant of x and try y cotangent of x. Actually, no, you can't do cotangent of x yet. Well, no, I think I told you. I think we did. I'm going to skip that one. You can check the answers. I think you have the formula booklet. You're given the formula book. You're given these formulas. You can freeze frame this for a second, or I think you have the formula book. The answers are all, here's all the derivatives you get. Okay, I think that's basically it. Yep, you're going to work on 18A.